Hello everyone. When it comes to nested data structures with dictionaries and lists, you can think of infinite combinations. For example, we can have a dictionary which contains lists, which contains other lists, which in turn contains other dictionaries, which in turn contains other lists. It's kind of dizzying to think about that much level of nesting when it comes to data structures. We are going to cap ourselves to 3 levels of nesting as part of today's lecture. In this video, I'll be covering the concept of binning or bucketing, which is going to enable us to represent data using dictionary of list data structure. This is a very important concept with respect to project P8, which is a difficult project. Please come back to this lecture video and the corresponding demo video, which will be the following video, if you want help with respect to project P8. Let's get started by considering a tornadoes dataset. Let's say that every entry in my tornadoes dataset has a specific year during which that particular tornado impacted the world, along with other information. The concept of binning or bucketing is categorizing your data in such a way that you have various buckets that represent part of your data. Let's consider year as a bucketing factor here. The process of converting your list of list data structure into dictionary of list data structure by performing bucketing or binning is very simple. You just write a for loop to iterate over all the rows in your list of list data structure, and you're going to look up the value corresponding to the column based on which you want to perform the binning. For this example, we are going to consider year column as the bucket creation column here. Let's take into consideration that we have a tornado row where the year is 2018. We are going to take that particular row, which is represented using one of the inner lists using the list of list data structure, and we are going to put that row into the corresponding 2018 bucket. In the next iteration, let's say that your tornado has year as 2019. You're going to take that particular list and put it into the 2019 bucket here. Each bucket is going to be represented using list of lists, just like we represent CSV using list of lists. We are just categorizing our CSV rows based on a specific column's value, and the categories here are buckets. The buckets themselves are going to be represented as the key value pair within your dictionary here. Your key is going to be your bucket value, which is going to be year in this particular example. The value corresponding to that particular key is going to be the list of list data structure, which keeps track of the rows within your data set, which got added to that particular bin or bucket. Let's consider the tornadoes dataset as an example here. Let's say that this is our list of lists which is stored inside the variable rows. We have 3 columns here: the year column, the name of the tornado, and the speed of the tornado. The bucketization or binning process is going to take this particular list of list data structure and convert that into dictionary of list data structure. Observe that you have bucket for every unique year, and within that bucket you're going to represent the list of list data structure, which is going to store all of the rows as inner list here. So we have 3 keys: 2014, 2015, and 2016, and the corresponding values are going to be the list of lists which represent the rows that have that particular year for the tornado. Once you move the data from the original list of list data structure into this dictionary of list data structure, you can imagine using this data structure to answer specific questions about each of the buckets. Let's say that I'm interested in computing the median of tornado speed for every year within my data set. It is very easy for you to perform such a computation because you have already structured the data in such a way that you have buckets using the years, and within each year bucket, you're going to have the corresponding rows from your original data set. I'll wrap up this video here. In the next video, we'll go through the demo problem for converting list of list data structure into dictionary of list of lists.